All right, so chapter 10, we're going to be taking a look at how to count things. And I don't mean like, do I count on my fingers or do I count on the dots on the numbers? Like, that's not what I mean. But things that end up being a little bit more complicated. So 10.1, we're going to be taking a look at systematic listing, where we simply list out the things that we're counting. And so these tend to be smaller amounts of things we're counting. I mean, if it gets too big, we're not listing things out. We're going to have other strategies to be able to employ. So we're going to consider a group of students: Abigail, Bailey, Nate, David, Elias, and Macy. And we're going to be given some specifics about how to put them in different groupings, okay? So we're going to find different ways of forming the following groups. So the first one is that we're going to create a group of two people. They're going to be a president and a treasurer. And we want one of them to be a boy and one of them to be a girl, okay? And so we're just going with, I'll list them in case these are names that are not super familiar to you, but they're names from my life. That's why they're all showing up in here. So, but this is, Abigail would be a girl, Bailey's a girl, Nate's a boy, David's a boy, Elias is a boy, and Macy's a girl. Okay, so for clarity. So anytime you see them listing things like that, they're going to go with normal conventions of things. And I realize that there's some names that go both directions. They're not going to use names that are going to do that. So it's going to be pretty clear if you see anything in my math lab like this, okay? All right, so we want a president and a treasurer, and we want them to have one boy and one girl, all right? And we're going to list how many ways that can happen. So we're just going to start with the first person on the list, and I'm going to use the first letter of their name, and you'll see that happen inside of my math lab too, where they specifically choose names that are all different at the beginning so that we can do it that way. That way I don't have to write out everybody's name every single time, because that would be even more tedious than what we're about to do, okay? So we have Abigail. She's listed first. So Abigail could be the president. So we're going to list the president first, treasurer second. Everybody good with that? Okay. And I'm only really doing that because that's the order it was given to me in the problem. So if Abigail is the president, who could be the treasurer with her? Nate. So it could be Abigail, Nate, or it could be Abigail, David, or it could be Abigail, Elias. Okay? And that is every option for how Abigail could be president. And then we go to the next person, and we're just going to go down the list. Who's after Abigail on my list? Bailey. So now we're going to do Bailey. Bailey could be president, and she could have, who is her treasurer? Nate, or David, or Elias. Okay, everybody good with that? That's every way that Bailey can be president, every way that Abigail can be president. Who's our next president-elect? Macy. Okay, so you guys chose Macy. If you were just going down the line, you might have decided that you were going to choose Nate next, and that would be fine too. So there's not an ordering of how they have to be done. So we'll go with Macy just because she's the third girl on the list, and then we'll flip it around and we'll do all the boys, okay? So we could do Macy with Nate, Macy with David, and Macy with Elias. Now these, there's 9 of them here, right, are all the ways that we could have a girl as president, correct? And now we're going to flip them. And in fact, if you just simply flip every single one of these, you're going to have the same thing with the boys as the president and the girls as the treasurer, right? Or you can go down the list. So I'll go down the list, but just so that we recognize we have a couple of options on how to sort of think through getting the other half of the list. We could start with one of the boys. So we're going to start with Nate. So we could do Nate and Abigail, or Nate and Bailey, or Nate and Macy. David and Abigail. David and Bailey, David and Macy, or Elias and Abigail, Elias and Bailey, Elias and Macy. Okay, does that make sense? Because we're actually talking about this in terms of like counting, how many are there? 18. So there are 18 different ways that we could have a boy and girl treasurer and president where they don't match. Right? One of each. Okay, does that make sense? Okay. If they get much bigger than this, we're about to do one that's going to get a little bit bigger, it becomes, well, it may have already felt to you like it was annoying, but it becomes much more annoying the more they are, right? Like this had 6 people, but what if there had been 10 of them? And you had to do this. Are you with me? Okay, so the size of these is restrictive to how maybe reasonable it is to do this strategy. All right, let's do another one. This one we actually have a president, a secretary, and a treasurer. Okay, so we have three people that are going to be grouped. It's the same people's names. Okay, all the problems I'm going to use are the same people's names. So we have three people in our grouping, and we want the president and the treasurer to be the women. So again, because it's listed president, secretary, treasurer, I'm going to do them in that order. So president first, secretary second, treasurer third. Are you with me? Okay, so it says that I want to have a girl president and a girl treasurer. So I'm going to leave a space, and I'll just go to the next one. So I'm going to do Abigail and Bailey first. Okay. What about the treasurer? I don't mean treasurer. Excuse me, secretary. Could be Nate. What else could it be? Who else could it be? Could be David. Who else? Elias. It could be Macy, right? It didn't say, like on the last one, that the secretary had to be a boy, did it? So be careful not to read into it what's not said. It could be that Macy, and we had all girls as the executive branch of whatever club this is. I don't know. Okay, does that make sense? Okay, so that's with Abigail as president and Bailey as the treasurer. So maybe I don't have Abigail and Bailey. Maybe I have Abigail and Macy. Okay, pretty good. Abigail, Macy. So I could put Nate between them. I could put David in there. I could put Elias in there. Or I could put Bailey in there. Right? Is there anybody else or any other arrangement with Abigail as president that I could do? I've listed all of them, right? So I have to remove Abigail from that first location now and move on to doing someone else as my president. So it is much easier to do all of these if you exhaust a specific person in a category and then move on so that you don't end up accidentally repeating somebody, right? Writing it there twice or forgetting something. So we've written every possible way that Abigail could be president, and we did her first. Now I need another girl to be president. Who shall I have be president next? Bailey. Okay, so I can do Bailey. I can still do Abigail, right, as the treasurer. I didn't say she's not allowed to be anything. She's just not allowed to be the president still. So I can do Bailey and Abigail like this with Nate, with David, with Elias, and with Macy. What would my next sort of grouping be? Bailey president, and what? Macy is treasurer. So I've got Nate between, David between, Elias between, and then Abigail actually between, right? Now I'm done with Bailey as president. Agreed? So who's my last person who could be president? Macy. I'm going to shift these over because I'm running out of space. So I could have Macy and who? Bailey? Okay, so Macy and Bailey. And so I can do Nate, David, Elias, and then Abigail, right? What am I missing? Macy and Abigail, right. So I need Macy at the beginning, Abigail at the end. I have Nate, David, Elias, and then the last one would have Bailey in the middle. Okay, so systematic listing means that there's some sort of a pattern and organization that you're not going to list people twice and that you're not going to forget people. So keeping the structure where it went Nate, David, Elias every time helps to do that on this particular one, right? Every time I do it, I use the same three in the middle in the same order so that I don't forget any of them. So I encourage you, and it doesn't mean that your systematic listing and mine have to match, right? Like you might be thinking of it some other way, but have some sort of a patterning of what you're doing so that you don't end up making a mistake and forgetting someone or including them twice. How many of these are there? 24. Okay, the next one's different. What's different about the way that the next one's worded? There's a couple things, actually.
It doesn't have specific roles, and it doesn't have specific genders.
Right. There's no specific roles, right? The other one said president, secretary, treasurer. It had specific, like, descriptions of what their job was, right? That matters. It's different if I don't have that. And there's nothing that restricts whether they're boys or girls or if it's two of the same, right? There's no restrictions on that. And all the other ones had some kind of restriction. So all those things are going to affect how many people or how many committees, I can create or how many groupings I can create. So this one just says any two people. So again, I want to do it in some sort of a systematic way. So I'm inclined to stick with one of the people and list all the people they could be grouped with first. And since she's listed first, I'll start with Abigail. Okay. So Abigail could be grouped with, and if I just took it on the list, Bailey. It could be Abigail Bailey. Who else could it be with Abigail? Yeah, Nate. Or Abigail and David. Abigail and Elias, or Abigail and Macy. Now, that's all the groupings of Abigail. And unlike the other ones where I was flipping them, I don't flip them here. Why? There's no roles to play. That's why the role part mattered in the other one, right? If I'm a president or I'm a treasurer, those are different jobs. But here, they're just on a committee together. So if I have an Abigail Macy committee, that's the same as having a Macy Abigail committee. I'm not going to list them twice. So there's not going to be any other A's listed as I move forward. She's been grouped with every other person once. So now I'm going to go to the next one, which is Bailey. So I'm going to go to Bailey, but I'm not going to do Bailey Abigail. I've already listed that. So who would I group Bailey with? Nate. Or Bailey with David. Bailey with Elias. Or Bailey with Macy. And notice there's one fewer. There's not really one fewer, right? But it looks like it. Why does it look like there's one fewer?
Because A, B, A is on the other.
The AB was already in the first list. So it's fewer than I had before, but only because one of them was already listed somewhere else. Okay, so no more Abigails, no more Baileys. Who's next? Nate, if I go in order, right? Nate. So Nate and Noel said David, that's right. And then Nate and Elias, and Nate and Macy. And notice, again, it looks like there's one fewer because I've already listed Nate in two other locations on the other two lists. What might you list next? David Elias, and then David Macy. And what's missing? Elias Macy. Okay, so how many of these are there? 15. Okay, so inside of my math lab, this is one of those places where they've got parts A and B where I can go back and I can make sure that you don't end up getting not partial credit when you really had partial credit. So if you make a mistake in writing this list out, obviously you're probably going to have a mistake in writing how many match that, right? So when I go back in and look at quizzes and exams, this is one of those places that I go and say, hey, okay, if they made a mistake on part A, but that doesn't mean that they should be penalized for not being able to count on part B. They can count, right? And I make sure that those numbers match. So just be aware of that. Okay, so the next thing we're going to do is, in this particular section, is that we're going to look at rolling a die, okay? So this chapter feels very much like every problem looks a little bit different, and I realize that. It does not benefit you for me to try to go in and find out every possible scenario that they could take the information and apply it to. So I'm trying to give you a smattering as we work through these sections of different scenarios where these concepts apply. But if they feel like they look a little bit different, that's going to be why. They are applying the same concepts, but they are applied all a little bit different contexts. So this one's going to be rolling some dice, okay? So you've probably all rolled die before. We're talking about the standard six-sided die, right? Like the ones that you play with Monopoly or Sorry, right? So there's the numbers 1 through 6. They've got dots on the sides, right? So when you're teaching this, like in public school, they tell you should call them number cubes because dice means gambling. It's terrible, I know. But they're dice, right? That's what we're looking at. And so what we're going to do first is we're going to create a table of the different options of how the dice can show up when we throw them. And one of the nice ways to do that is to create a chart that looks kind of like this. And what we're going to do is we're going to list across the top and then down the left-hand side all the different options that the face of the die could roll. So, for example, on top, I'm going to write a 1, a 2, a 3, a 4, a 5, and a 6. Those are my options. And then along the side, I'm going to list the same things, right? So the top is like die number 1. And if it helps you, you can think about them being colored, right? Like you've got a red die and a blue die or something like that to sort of distinguish between them. So the top is going to be one of our dice, and then the side is going to be the other die. And so we're going to have the same numbers, 1, 2, 3, 4, 5, and 6. And this description says to create a table of summations of the two dice. So for example, if I'm looking at, I'm just going to move over kind of to an arbitrary location on my chart. If I roll a 4 and a 3, it's this location, right? And if I roll a 4 and a 3, what do I get for the sum? Get a 7, right? So I would write a 7 in that spot. Now, I'm not going to do it arbitrarily because there's very nice patterns that show up that are making this easier to do. So take a look at the first line. So this first line takes the number 1, right, on row 1, and it adds it to the 1, 2, 3, 4, 5, and 6, which means that the 1 plus 1 is a 2, and the 1 plus 2 is a 3, and the 1 plus 3 is a 4, and then you have 5, 6, and 7, right? Not only that, but if you did the first row, you could do the first column and it would match. So you could actually do that next if you wanted. And you said, okay, well, I can do the same thing going down, right? I can add 1 plus 2 this way, and that's a 3. And 1 plus 3 this way, and that's a 4. And then 5. And then 6, and then 7. So if you want to fill them in that way, you could do that. Okay? But you could just write them all in horizontally first. I mean, you could do it that way too, and it wouldn't hurt anything. Right, the next one starts out 2 plus 1 is 3, but the next one where I'm at, let me do a highlighter here. Come on. If I'm here, right, 2 plus 2 is 4, and then 2 plus 3 is 5, and then 6, and then 7, then 8. What's my next row going to be? I've already got a 4 in it. What's next? 5, 6, 7. Right. I'm just increasing by 1 every time, right? The table itself is not difficult to compute. What's after my 5? 6. Okay. And the last row? Okay. Everybody good with that? Here's what I want you to notice about this table. You intuitively know this, even the little kids like, my 10-year-old or whatever, she sort of intuitively knows that it's less likely that she's going to roll a 2, right, a sum of 2 on the dice than it is that she's going to roll a sum of 7. But can you see from the table why that makes sense? Do you see all the 7s that are in the table compared to the number 2 or the number 3? There's a bunch of 7s, and there's only 1 2, and there's only 2 3s, right? So this is actually a very good visual representation of how people tend to create board games, right? When they're wanting there to be an unlikely chance of something happening. You can also look at like the chances of rolling doubles. So do you ever have any board games where if you roll doubles, something special happens? Sorry is one of them. If you roll doubles, I can't remember because all the rules, it's been a while. But there's certain rules of things that happen if you roll a double in Sorry. I think Monopoly has a rule like that too. Is that true? I'm getting some nods on some heads. My kids played Life this week. That's not a rolling dice game though. That one's got a spinner. And there's special things in that too. But yeah, so when you're creating sort of unlikely events to happen in board games and you're doing dice, this is the kind of picture that the creators of that game would be thinking of, okay? So taking a look at the next page, we're going to answer some questions. It says, determine the number of ways of getting the following sum. And so the sums are going to be listed here. Sum of 4, sum of 11, odds between 6 and 15, and then multiples of 3. So what I'm going to do as we answer these is I'm going to go back to my table and I'm going to highlight them. But taking a look back at your table, we want to find all the places where we have a sum of 4. Do you see them? In fact, they occur in a diagonal, don't they? They do. They're all right here. There's 3 4s in my table. So as I'm looking at the answer over here, how many ways is it possible to get a 4? Well, 3 of them. And if you were asked to sort of list what those are, although my table doesn't do so, you could go back to the row and the column headers, and you could see them. It's a 1 and a 2. Sorry, not 1 and 2. 1 and 3, 3 and 1, and 2 and 2. Right? Those are the rolls that could happen on my, say, red and blue die as I'm looking to try to get a sum of 4. Okay, so it didn't ask me for that on this, but it could have. Yep, Jamora.
I have a question. So on the last one, when it said a committee of 2 people,
Yeah.
you said not to repeat it,
Yeah.
switch it. But on this, you switched the 3 and the 1, but you didn't switch the 2 and the 2.
It's still the number of ways it can happen. So again, if you think about your die, right, and you have one that's red and one that's blue, if I roll the one red die, it could come up with 1. And if I roll the blue die, it could come up with 3. That's a different roll than rolling a 3 on the red die and a 1 on the blue die.
So wouldn't it be different if it's a 2 on the red and the 2 on the blue and a 2 on the blue and a 2 on the red? Or
But there's only one way to get a 2.
okay.
Yeah. So when they repeat the number, like on that example that you just mentioned, when there's a 2 and a 2, there's only one way for the 2 to show up on the red die and one way for it to show up on the blue die. There's not any other 2s that can come up. Yeah. And this is different than my committee one, to mention that one, can you mention before, is because my committee one was actually talking about people, not the die itself, which has different options of how that can be rolled. So it's a little bit different of a scenario. Yeah. Okay. How about, what's my next one? 11. How many 11s are there? There's 2, right? I can roll, again, if my top die and my left die are different colors, I can roll a 6 and a 5 and get this 11, or I can roll a 5 and a 6 and get the other 11. So there's 2 different ways that the die could actually roll and give me those numbers. So I have 2 options here. Odd's a little different. I'm actually going to highlight those. So if we look for the odd numbers, I would have the 3s, the 5s. That's not very good. Let's try that again. 5s, the 7s, the 9s, and the 11s. How many is that? 18. Without counting, do you know how many evens there are? There's also 18. So there's some symmetry going on here, which we recognized when we created the table, right? That there was some symmetry going on for sure. There are 6 rows and 6 columns. 6 times 6 is 36. That's the total number of different things that could happen. Some of them are repetitive of one another, I get that. But there's a total of 36 different things that can happen. Half of them would turn up even and half of them would turn up odd. Okay, so those are equally likely things to happen. How about between 6 and 15?
Or no, 29.
Okay, so first of all, recognize that the phrase sounds funny. Why? There's not a 15 or a 14 or 13, right? So even though it describes things, it doesn't actually have to mean they exist in my table. So we're really looking at the numbers that go from 6 to 12, right? And one way to do that would be to count all the 6s up to 12s. How else could you do it? Yeah.
Include the 6s on there?
It said between, so we're not going to. Thank you for noticing. Between isn't going to mean we don't include them. I definitely wrote that down wrong, so we're not going to include them. So we're going to go from 7 to 12. We wouldn't actually include 15 either. We would go 7 to 14 if it existed. But okay, so I could count up all the 7s, 8s, 9s, 10s, 11s, and 12s. That's one way to do it. What else could I do? What if I counted up the 2s, 3s, 4s, 5s, and 6s? Could I do that? Yeah, and then subtract them from 36. Now, on this one, that probably doesn't really matter. You're almost counting the same amount either way. But if it said something like, instead of saying between 6 and 15, it said between 4 and 15, then it might make more sense to think what's not included in this list instead of what is included, right? All right, so counting of them. How many of them do you get that are 7, 8, 9, 10, 11, and 12? I think Noelle said it earlier. 21. Does everybody get 21? Okay. So there are 21 ways that this can happen. Okay, what does the word multiples mean? What are multiples of 3? What does that mean? Okay, anything that's divisible by 3. You might think of it as your multiplication tables of 3, right? If you were to skip counting or counting by 3s, 3, 6, 9, 12, 15. So we could ask the same question about multiples of 4, right? 4, 8, 12, 16. Those are multiples of 4. So as we're looking for multiples of 3 within my table, I'm looking for 3, 6, 9, and 12. So I'm going to use a different color highlighter because I've already, actually, maybe I can erase the yellow. We'll see. I'm going to mess up my 9. Okay. So we're going to do multiples of 3. So I have 3's here. Actually, let me do it with a brighter color. So here's my 3's. Here's my 6's. Here's my 9's. And over here is the 12. So how many do we find? There's 12 ways of doing this. Okay, so good? All right.